Here we are importing the necessary libraries and modules for our AI-powered content writing system. We have the OS module for interacting with the operating system, RE for regular expressions, Beautiful Soup from BS4 for web scraping and parsing HTML, optional from typing for type hinting, DDGS from DuckDuckGo_search for performing DuckDuckGo searches, LangChain, prompt template, initialize_agent, and tool from LangChain for building our language model chain and agents, and finally chat OpenAI from LangChain_community.chat_models for integrating with the OpenAI API. Here we have a class called Chat OpenRouter that inherits from Chat OpenAI. This class is designed to interact with the OpenRouter API, which is an open-source alternative to OpenAI's API. The Chat OpenRouter class has three attributes: OpenAI_API_base, OpenAI_API_key, and model_name. These attributes store the base URL of the OpenRouter API, the API key required for authentication, and the name of the model to be used, respectively. The __init___ method is the constructor of the Chat OpenRouter class. It takes several parameters, including the model_name, OpenAI_API_key, and OpenAI_API_base. The OpenAI_API_key parameter is optional and defaults to none. If no API key is provided, the method attempts to retrieve it from the environment variables using os.getinv, OpenRouter_API_key. Inside the constructor, we call the super.__init__ method to initialize the parent class Chat OpenAI with the provided OpenAI_API_base, OpenAI_API_key, model_name, and any additional keyword arguments passed to the constructor. By creating this Chat OpenRouter class, we can easily interact with the OpenRouter API and utilize its language model for various tasks, such as generating text or answering questions, while still leveraging the functionality provided by the Chat OpenAI class. Here we have a function called clean_HTML that takes an HTML content string as input. This function is responsible for removing unwanted tags and their content from the HTML. Inside the function, we create a Beautiful Soup object called soup by passing the HTML content and specifying the HTML parser. Beautiful Soup is a library that helps us parse and manipulate HTML easily. Next, we iterate over a list of tags that we want to remove, such as head, nav, footer, style, and script. For each tag, we call the decompose method, which removes the tag and its content from the parsed HTML structure. Finally, we return the clean text content of the HTML by calling soup.get_text. We specify a space character as the separator to separate different text elements, and we set strip equals true to remove any leading or trailing white space. This function helps us extract the relevant text content from the HTML while removing unwanted elements like headers, footers, styles, and scripts, making the content more suitable for further processing or analysis. Here we have a function called search_with_metadata that takes a search query as input and returns formatted search results. First, we clean up the query by removing any leading or trailing whitespace and quotes. Then, we use a context manager to create an instance of the DDGS class, which allows us to perform a DuckDuckGo search. We limit the results to a maximum of 3. If no results are found, we return a message indicating that. Next, we iterate over the results and extract the title, URL, and page content for each result. We clean the HTML content using the clean_HTML function we defined earlier. We then format each result into a string that includes the title, URL, and cleaned page content, and append it to a list called formatted_results. Finally, we join the formatted results with new line characters and return the complete search result string. If any exception occurs during the search process, we catch it and return an error message with the exception details. Next, we have the get_search_tool function. This function creates and returns a search tool that we'll use later in our agent. The search tool is defined with a name, a function it should call, search with metadata, and a description of what the tool does. The search with metadata function will search the internet for a given query and return cleaned up results, including titles and page content. Here we have the instantiation of the Chat OpenRouter class, which is a custom wrapper around the Chat OpenAI class from the LangChain library. This allows us to use the DeepSeek model hosted on OpenRouter for our AI agents. We're passing in the specific model name, the API base URL for OpenRouter, and the corresponding API key. This LLM object will be used later to power our search and content writing agents. Here we have the section where we define our first agent, which is a search agent. This agent is going to be responsible for searching the internet for relevant information based on the topic provided. To set it up, we use the initialize_agent function from the LangChain library. We pass in the get_search_tool function we defined earlier as the tool for this agent. This gives our agent the ability to perform internet searches. We also specify the language model LLM we created earlier for the agent to use. This model is responsible for understanding the search query and generating relevant search commands. The agent_type parameter is set to 0-shot React description. This means the agent will attempt to understand the query and generate search commands without any additional training or examples. Finally, we set verbose to true to get detailed logging output from the agent, which can be helpful for debugging and understanding what the agent is doing. Now, we're moving on to defining our second agent, the content writing agent. This agent will be responsible for generating the actual article based on the topic and the information found by our search agent. To create this agent, we first define a prompt template called content_template. This template takes two input variables, topic and info. The template provides a structured prompt for the LLM, instructing it to write an in-depth article on the given topic, using the provided information as the basis, and ensuring that the content is informative, engaging, and well-structured. Next, we create an LLM chain called content_chain. This chain combines our LLM, which is an instance of the Chat OpenRouter class, with the content_template we just defined. The LLM chain will use the prompt template to generate the article based on the topic and information provided. Here we have the automate_content_writing function. This is where we bring everything together to generate an article automatically. First, we take in a topic parameter, which is the subject we want to write about. The function has two main steps. 1. We use search_agent.run, topic, to search for relevant information on the given topic. The search_agent is our first agent that utilizes the search_with_metadata tool to fetch and clean search results. 2. Once we have the search_results, we pass them along with the topic to content_chain.run. This is our second agent, responsible for generating the actual article content based on the topic and the gathered information. Finally, we return the generated article, completing the automated content writing process. Here we have the main part of our script. This is where everything comes together. We start by checking if the script is being run as the main program. If it is, we define our topic, the benefits of AI in modern education. Next, we call our automate_content_writing function with this topic. This function, as we discussed earlier, uses our two agents to first gather information and then generate an article based on that information. Finally, we print the generated article to the console, providing us with the final output of our program. This is where we get to see the fruits of our labor, the AI-generated article on our specified topic.